just use this one. Hopefully everyone can still hear me. We're early, I guess, but the important stuff is for a few slides down. So I'll just sort of start. I had a quick question, because this is sort of a more MySQL-oriented crowd, but I'm wondering how many of you guys are actually using Postgres already? And of you, how many were using Postgres before Monday's announcement that Oracle was buying MySQL? We seem to have a few newcomers on there. So this talk is sort of scaling with Postgres, and this is I guess a trimmed down version of it. And just sort of to give the overview of, I guess, a general strategy of how you should approach this. And in theory, this is not really Postgres specific. It sort of is because of the different ways that Postgres scales compared to other database systems. But sort of the path that you take when you try to scale a database is similar no matter what database you use. So you might recognize some of this even if you're not using Postgres now. So I have to start with a disclaimer. If you look at the really big sites, and by really big, I mean, Google, Facebook, like any of these large companies have really large data sets. They're all using some, probably completely homebrew, but I mean some level of homebrew solution and custom codes. And just try to use out-of-the-box tools, you're probably not going to get to that size, right? And everyone thinks they're going to be the next Facebook, and they want to figure out, like, how do I do this using like built-in tools and freely available software? And probably the real answer is you're just not going to do that, right? So the solutions are getting better, and so that's good. You can get close to that stuff, or you can get along that path, but just sort of realize there aren't really any shortcuts to that. The really hard problems are still really pretty hard. That's where good engineering comes in. So just a quick overview of who I am, and I guess sort of how I ended up here. I work at OmniTI, and we manage several databases that are like terabyte scale databases. We run like top 100 websites, OLTP style, so we're familiar with both OLTP and OLAP. We use Oracle, MySQL, and Postgres. We use other stuff, more limited, and we don't necessarily use it in that order. We probably use more Postgres than anything else, but we also do Oracle, and we also do MySQL stuff. So it just sort of depends on, usually it depends on what the client is running, is what we end up supporting. But in cases where we can pick or change technologies, then we just try to get a good match. We are hiring, by the way, since I have a few minutes to kill. So if you are a deviant for a job, there is a posting on our website at omniti.com. So scaling database is sort of 101. This is sort of the overview of what you need to do. And we'll kind of move through this quickly and go into a little more detail going on. So step one, of course, is like you implement your grand scheme of this is the best database design ever, right? And you stick it on your server and you have it going. And then there's sort of this mix of the next three sections where you're doing tuning, right? Optimizing queries and optimizing schema. That's sort of the next level of scaling where you realize, well, geez, half these guys can't actually write SQL, or we kind of laid these tables out wrong, or your business needs sort of change once you actually start running it. So you need to go back and revisit those things. And these three things, you can do a little bit of one, a little bit of another, and have to go back and forth. But it's sort of the same, again, on most database systems. This is the path you're going to follow. Once you get done with that, you then generally start to do caching, and you start to try to throw hardware at your problem. Right? This is sort of the next step that everyone has to go through. Following that, you start looking at replication solutions, doing different kinds of things, and what you choose will probably depend on your type of workload that you're using, what you hope to accomplish. Right? And then the last step, what I would say, hopefully, being, I guess, a classical DBA in nature, is doing federation, breaking up your database amongst different servers and sort of throwing out all the relational stuff. Is in theory, your last step, or down the line of ways. Right? So let's talk about implementation. Implementation, right, you sit down in a room with like 5 other guys, you talk about what you need to do, you do all these foreign keys, you lay out your tables, it's like a beautiful scheme. Everyone's really happy. It's the best database design you've ever seen. It's all relational. Like Todd himself is like patting you on the back. It's great. But actually, most of it is generally irrelevant. And I only say that because it's not that those are bad things to do, and I would generally recommend learn normalization and follow it and do good database design work up front, because it does save you a lot of problems in the end. But anyone who works as sort of a scalability consulting or in that sort of realm will tell you most of our clients really suck at this part, and so they have scalability problems because they haven't done this, but we still try to figure out a way to get them to scale. even most of the large companies that have gone public, you look at their presentations, and they're just riddled with like, here's all the stupid things that we did while we were trying to scale up, right? So it's sort of irrelevant. You can still scale even if you've done bad design. That's what we do for a living, sadly. But it pays bills. So what's really important when you do your implementation, in my mind, is step one, you've got to do monitoring. And again, this doesn't really matter what database you're using. If you are using Postgres, there's a module called Check Postgres, which if you Google for that, it is hands down the best, script, piece of code, or whatever that you can use to monitor your Postgres system. If you don't want to use that itself, it's a Perl script that runs in Nagios. Some people don't like Perl, some people don't like Nagios. You should at least go through and steal the ideas that are in there, right? It's basically just queries you run against your Postgres system to see what's good or what's bad. So if you're not going to use this, re-implement it in whatever solution you want to use, right? But you need to be monitoring to see what is going on. I mean, that's sort of critical day one. And it seems really obvious, but honestly, a lot of the people that we talk to, even if we do like sort of the short, go in for a few weeks and see the things you're doing wrong, like the top of our list is usually you're not monitoring things correctly, right? So this will lay out and sort of get you over those hurdles. The second step is to do trending. This one is even more overlooked than monitoring. Doesn't seem quite as obvious, but it's really important as you try to scale. You need to be able to understand what your workloads are and how that affects your hardware. Right? Most of that actually, again, doesn't have to be database specific. If you're measuring how fast your disk, rate of disk growth is, I/O, CPU, and memory usage, and those things that are essentially really system level pieces of information, measuring those and being able to see how that works over time and how quickly you're growing in certain areas will tell you, how long it's going to be before you outgrow your hardware, or if you need to buy more hardware in a certain area, or if you're, using too much I/O for some reason, you might be able to go back and refactor how your application works. So these are really what I find to be the two really important things to do when you do that initial implementation. Make sure you have monitoring, make sure you have trending, right? And again, the solutions don't really matter. Cacti, I think, is probably the most popular trending solution. We have one that we call Reconnoiter, which I can't spell, so I just put Noit. But I think Google either of those words and you should find it. And that's sort of our in-house homebrew one. It doesn't use RRD, but it makes pretty graphs, and you can kind of go back and look at things over time. So that's really all that you need to do. It doesn't have to be super fancy. Monitor the basics. If you can monitor certain specific things, like if you have one table that's business critical, because here's where all the inserts are coming in for photos that I'm uploading, and you maybe need to watch that table more than anything else, then you can make custom monitors in any of these pieces of software and monitor that and trend that information specifically. But in a general sense, get a hold of your hardware and watch what's going on. Measure maybe like transactions per second and a few of those things. But have that stuff in place so that when you start to see problems, you can look back and see over the last 1 or 2 or 3 months. And especially with trending, I harp on it only because it's really hard to do trending after the fact, right? If you run for 6 months and you start to have problems, you can implement monitoring, and that's easy. You've got it. If you have 6 months and then you have problems, you can't just implement trending, right? Because you can't go back and figure out what was going on 6 months ago. So you really have to get there up front and make sure that you're doing that stuff ahead of time. All right, so you got all that great stuff in place. The next step, if you're using Postgres, is to get the basics right as far as tuning your system. I forget, Postgres has like 200 different variables to tune. There are about 10 that actually matter. And a couple of the Postgres guys and myself wrote up a wiki page on how to tune your Postgres, which is basically the no foot gun approach to tuning it. Right? Here's the 10 things you actually need to know. A few of these are going away with Postgres 8.4, so that's even better. But it's pretty straightforward. The important thing is you don't want to be doing something dumb, right? And that's what this wiki page will help you do. Beyond that, there are other things that you'll probably want to do eventually for tuning, but they are often very workload dependent. Xlogs and checkpoints and vacuum strategy, if you're running Postgres, you've probably dealt with all those on some level, but how deep you need to go into that, it's so workload dependent, it really does depend. Some people never have a problem with checkpoints because they're doing mostly select, own, and query, right? If you're doing heavy write loads, you probably have some kind of checkpoint issue going on, or you may eventually hit that. So those are the things that you may have to deal with someday down in the future, right? It's stuff that we have to deal with a lot. what we're doing because we're doing it at such a large scale. But it's not the initial, like you really don't need to worry about a lot of the tuning parameters like CPU tuple cost, like, oh, I need to change that. If you follow like the performance list for Postgres, there's a mailing list dedicated to performance problems. Nobody ever like posts a query that's having problems. Someone says, hey, go up, go modify your CPU tuple fraction cost, because that's not right. That's just never an answer. It is done sometimes, but it's sort of way down the line, right? And you probably will solve problems in different ways before you have to do that. So optimizing queries in Postgres is actually pretty awesome. I might be biased, I don't think so, but explain in Postgres is the best explain tool out of any of the databases that I've seen. It really gives you good information and insight into what's going on. One of the awesome things that has been added, I think it was in 8.3, when it does sorts, it like tells you how much memory it actually needed to do the sort and which sort algorithm it uses. That's really awesome because sometimes it's just a matter of saying, allow this connection to use a little more memory for sorting, and now my query is like super fast, right? But if you don't know how much memory that's supposed to be, it will take you all day to figure that stuff out, right? And there are 3 different versions of explain that you can use. There's been a lot of presentations written on them, and I've done a few on how to use explain, but just know explain tool is your friend for optimizing queries. When we talk about using explain, all that really means, right, is you're writing your queries tuned to your database planner. And again, that's sort of universal truth. It's why you see when you port an application from one database to another, the queries don't always, just work on the other system. And this is true if you're going from, MySQL to Postgres or Oracle to MySQL or whatever. Even if the database is supposed to be 100 times better, if you've written those queries tuned to the planner, and now you switch database systems, now you have a different planner, right? Different optimizer, different executor. So you should expect different performance when you switch database systems, right? If you're going to scale, realize that you're probably sort of betting your farm on whatever system you've chosen. It is hard to get out of one system or another. You are going to have to tune those queries, to the database planner. It's hard to avoid that, and getting that sort of intimate knowledge is where you're going to end up, down the line as you start to make things bigger. Optimizing schema, pretty straightforward. It's going back, reviewing, do I have indexes I don't need? Do I need new indexes for the queries I'm running? Postgres gives you partial indexes and functional indexes. A lot of times people will exploit those to make certain queries really fast. You go back in, you clean up your data types because you're kind of sloppy to begin with or whatever. You use the wrong one. Adding and removing tables. I threw denormalize on here, although I'm not a big fan of it. Like sometimes it actually is the answer, so I suppose I had to put it on there. I don't jump at that and say you should do that right away, but again, it's one of those, usually there's cases where you have a specific, sort of business goal of I need to answer these questions and this quickly, and the answer becomes denormalize that data and then you can serve it up and do what you need to do. Depending on how you originally designed your schema, denormalization doesn't always work or becomes a necessity before it needs to be, and so that's why I was, I'm sort of leery even to put the bullet in there, but sometimes it's an answer, right? And if you look at the tuning, right, optimizing queries and optimizing schema, I'm sure a lot of you are thinking well, when I've done this stuff, I haven't done it in this order. You may not do it in this order, and you're probably going to have to, sort of revisit old things and go back and forth between these different ideas while you're sort of getting your database tuned and working in a proper fashion. The thing is, if you're using Postgres, Postgres is pretty good at scaling vertically. Right? Meaning, if I just keep buying bigger hardware, it takes care of a lot of the problems for me. The problem with that idea, right, is if you have flawed database schema where you haven't tuned queries, you haven't, built at least a decent schema, or done the proper tuning, and it doesn't have to be really extensive, but at least the good stuff, then you're kind of getting in the way of yourself, and you're probably going to go into things like replication and bigger hardware before you really need to. So for Postgres folks, a lot of your time is spent just making the thing run better on the system that you have and trying to get performance out of that, right? On the other hand, optimization takes time, right? It takes a level of expertise a lot of people don't have. There's usually a lot of learning involved as you're going along the path trying to make things better. As new versions of the database come out, it changes the way the planner works, right? If you upgrade from one version to another, now your queries, some queries are faster, some are slower. You have to work that stuff out. So tuning is good and optimizing is good. But as everyone who really likes to do large-scale scaling and replication and sharding and all that stuff likes to say, it isn't really the ultimate solution. So take it to a point, right? It's good to do it, you need to do it, and I would spend a lot of time there before I got into more complex solutions that are going to be really hard to develop against. But, you know, understanding that it's only going to get you so far. At which point you get to this point. And I've been here a lot of times before, where you sort of spent all day and you're kind of tired or weeks on end, and you know, like you just can't optimize these queries. You really need better hardware. Trending, which I mentioned originally, right? Trending is like an awesome tool for going to someone and saying, look, not only are we I/O bound, we've been I/O bound for like the last 2 months, right? And we're only going to be more I/O bound because you only are doing more and more traffic on this database. So clearly, we're going to have to get, you know, more of something, right? Probably just in that case. When you start to throw hardware at stuff, you know, you've got to know, and I'll go back to trending, you've got to know which particular hardware bottlenecks you're fighting against. If you have an issue where, you know, one query is really slow, buying more CPUs probably doesn't really help that. It depends on the query, but and how often you're running it and how many concurrent connections you have, right? All of that stuff, there's a lot of variables involved. Looking at sort of the overall knowledge of trending and seeing which of those hardware, you know, in pretty graphics that everyone can understand, which of those hardware bottlenecks are getting in your way, makes it a lot easier to pick which particular hardware you're going to throw at it. Is it going to be more RAM? Is it going to be I/O? You know, are you going to buy more spindles? All that kind of thing. And also understanding that sometimes, like, you can buy RAM to get out of problems with disk I/O, right? Because you have more RAM, now it doesn't have to go to disk as much. So there are sometimes you can make those trade-offs, but if you don't know where your hardware bottlenecks are, you're probably not going to be able to do that so well. If you're going with Postgres and you're kind of thinking like, well, how high can I actually go? How far can I scale this from a hardware standpoint, right? At what point is Moore's Law working against me rather than working for me? This is sort of, I guess, anecdotal evidence, but I think most people that have run large-scale Postgres would agree on these numbers. You're probably not going to go much beyond 32 cores with a single Postgres. At that point, you're going to see sort of performance degradation that's not really worth it. But 32 cores is still a lot of cores, right? I see guys fighting with NODB, and you know, I'm like, well, you know, it's easier to swap to Postgres. Maybe you should do that because then you don't have to fight those sort of lower core level barriers. 128 gigs of RAM. I wouldn't say it's common, but you can get 128 gigs of RAM on a box these days. It's not completely insane to be able to do that. You don't need $500,000 to do it. So that's probably about the limit of what you should expect that you can go up to, and that one is still getting better, you know, each and every year. How far that will go is hard to say. You can use a lot of spindles. I don't know the most spindles anyone's ever used on a Postgres system, but it actually almost doesn't matter because they have table spaces available. So you can just keep adding spindles and segregating your data and doing it in sort of multiple ways, either dedicating spindles to specific tasks that you need to have fast, or you can just kind of throw it all together and, you know, just more spindles is better in that sense, and let your entire workload work over all the disks that you have. But thinking about, like, if you have this much computing power and this much hardware available to you, you know, at some point that will run out. Those are the limits of where you're going to go, and at some point you're going to have to move on to other things. Caching is sort of the next step, right? So you bought all this hardware, you've done as much as you can, and you're going to start caching things. Internally, this is usually done as materialized views. And actually, a lot of times this will be done before you buy new hardware because it's easier to do than actually getting someone to pay for more hardware, right? But in theory, you can actually lower your workload even if you maxed out your hardware, even if you're buying more hardware, and that's as far as you can go by doing this kind of thing. Everyone, I'm just going to kind of assume, is familiar with materialized views. General notes. See some shaking of head. So materialized view is basically, so everyone's familiar with views, right? Okay. So materialized view is basically taking the view and storing the actual data behind the view instead of just the query. Right? And usually, depending on your database system, there's different ways that you can actually set up materialized views. Normally, the way you do it in Postgres is one of two ways. One would be either you have triggers on your underlying tables that feed into the materialized view, right? So the view is sort of this complex query, but you break down, well, every time I update a row in this table, I need to update over here in this other table. The other table becomes a materialized view. The other way that's sometimes done is like you set up a cron job and say, well, this table needs to be refreshed every 5 minutes. All it does is basically run this view over here, query against a view, and dump it into a table, right? And so that's refreshed every 5 minutes. And the reason for that is that the calculated data is so much faster to query against than rerunning the view query every time, right? If you're running Oracle, you have sort of a lot more options, or they're sort of more built in anyways, as to how you can set up materialized views. So it's done a little bit differently, but most systems give you some ability to handle this. Even if you were running, MySQL 4 and MyISAM, in theory you can use the materialized view concept to say, well, I have a query and I'm just going to do like create table as with this query, and swap that in, and all my apps can hit against that table. It would kind of be ugly and sort of the older code base there, but hopefully you can use triggers or something a little more fancy than that. But that's the general idea of materialized views, right? It's taking these queries that are complex and storing the result rows in a new table that you'll query against from your application. People love external caching. Sometimes it's good, sometimes it's not so good. The biggest problem that I see with external caching is that you start to make trade-offs that you may not be aware about. And you're kind of giving up just the general idea of any part of ACID when you start doing this. If you're storing something like memcache and you're updating data over here, what happens if memcache goes down? What happens if there's a change between when your web page accessed memcache and the data got updated in a database, and that was just a little bit faster than how you had got that configured? So you might see some inconsistency in there. You've got to at least manage that process of how the stuff that's getting updated in the database is going to get updated in my caching solution. Sometimes, and again, it's sort of workload dependent. How fast do you need it to be updated? How stale can the data be? And it's not that any of those things are bad. I just think that people overlook. They're like, well, I'll stick it in memcache and I'm good. Like, there's no other thought behind that. And you end up sort of, kicking yourself later because it's like, well, I didn't realize I had just given up the fact that now my data can be inconsistent. And in some places, that's really bad, right? But if you can afford that stuff, it's good. The other thing I think people overlook a lot is just using sort of static files as a way to cache things. One of the things that's done in the PostgreSQL.org website is they have interactive documentation, right? So you can read through the docs. If you see something that doesn't look right, you send a note and submit that. It goes into a database where that's stored. But when you look at those pages, you're not actually looking at the stuff that's in the database, right? All of that stuff is just spidered out, and it's basically flat files that are being served up. And that runs, I think it's like every half an hour. It goes through and looks for any new comments that have been added, and then spiders those pages and regenerates the static file, right? Static file caching is like a beautiful scheme. If you can do that, and most people can do it more than they think they can, if you can use memcache, you probably can use some kind of static file thing. It's simpler to manage usually, simpler to set up, right? Apache is pretty good at serving static files, and Lydie is even better, and everybody can do that. So don't overlook that as a general solution. Once you've decided, I don't have to hit the database for everything. Some of this stuff can be a little bit out of date. That's sort of a simpler way to get at that. So I sort of run through a list here, and it's been pretty quick, but I think most of it's probably stuff that you guys have already done. And it's not like I've done anything revolutionary, right? Like I've talked about tuning and query tuning and writing indexes and all those kind of things. Materialized view might be a little more advanced. Doing some of these caching techniques, doing them smartly can get sort of complicated, and you have to work out the thing. But it's not revolutionary, right? Like everyone can do that stuff, I think. Maybe I have better idea of what the tech industry is and what it really is. But I think everyone can learn those techniques and everyone can apply them. And you can actually get really far with Postgres in that. I would say just given sort of basic caching and good tuning and buying bigger hardware, it's pretty easy to get into a top 1,000 website with that, right? Probably depends on your workload, might depend on what your business is. But since I know guys that have done this, I can say that I know this is possible, and doing it on one server, right? And the beauty of doing things on one server is it's really easy to develop against a single server, right? When you start to get into replication and federation, that's when not only does it become difficult for your DBA, it actually starts to become difficult for your programmers, because they need to start to understand that you're now working under a different paradigm, right? everything previous to that can be sort of done without programmers having any knowledge. And I probably have a lower view of programmers than I do DBAs and essays. So in my mind, this is the way to go. And hopefully most of you here are DBAs, right? I don't say this at like the Perl user conference, but using those methods and not having to complicate how you're going to actually produce your code on the back end just makes your business able to grow faster, makes you able to add features quicker, right, without having to overcomplicate things. And that's sort of one of the reasons why, and it's not really just a Postgres thing. If you're using Oracle, which, and by Oracle I mean, the big Oracle, not the new to be Oracle. Using Oracle, you can probably get, like an order of magnitude even higher than this, right? You can get into like a top 100 website on a single box running Oracle. Might take some tuning, might take a few years, right? As you're growing your business, you're going to tune these things. Depending on how fast you have to grow, you might have the ability to do that, but it certainly is possible. Right? But of course, everyone wants to talk about the sexy stuff. So, replication. Replication in Postgres is sort of at an interesting crossroads. 8.4, contrary to popular belief, will not have any built-in replication solution. So you don't have to worry about that. In Postgres, generally if you're going to do replication, you're going to use some kind of third-party product, right, for lack of a better word. And it's probably going to be trigger-based. There's not like horrible overhead like people say, like, oh, I can't actually use triggers because that'll blow up everything. I guess sort of don't believe that. I hear a lot of people come into like IRC, like, well, I heard about this solution, but it sounds like it's horrible performance and everything's bad. Sure, there is some overhead, but there's overhead sort of with any replication solution. There are things that you have to deal with, no matter what you pick. We just had, right, the fighting replication lag in MySQL. So it really doesn't matter what solution you pick. You're going to sort of have things that you're going to fight against. You need to figure out what those are and assess those kind of ahead of time to make sure they don't interfere with what you're actually trying to accomplish. But as long as you can do that, like, don't really worry about the methods that are involved. Just make sure they don't get in your way, right? And as a extra emphasis, add-on is like FUD for modular, right? Like everyone says everything should be modular and we should be able to plug in anything and do all this whiz-bang stuff. It doesn't have to be part of the core code. And then on the other hand, everyone complains like, oh, well, this replication solution is made by like some other guy, so it's not in the core thing. Kinda you got to get over that, I guess, if you're going to work with Postgres. I like built-in stuff as much as the next guy, but on the other hand, if you're a core Postgres developer and you develop a replication solution and you've been hacking Postgres for like 10 years, you probably know what you're doing, right? And the fact that it's done using the facilities that Postgres gives you is kind of a feature and will allow you to do a lot of interesting things like cross-version replication and things like that that aren't always easy to accomplish, with doing a built-in product. On the other hand, Oracle does it better than Postgres, I can't lie. MySQL does it simpler than Postgres, I still won't lie. There are things I like about both the MySQL replication solutions and the Oracle ones. And I would say Postgres is certainly a third tier when it comes to those two systems for different reasons. But on the other hand, since I've used most of the Postgres replication solutions and I've had pretty good results with all of them, I think they're all up to speed, or at least the ones that I picked are up to speed and can do a pretty good job. But not trying to sell you anything here. So if you're going to scale reads in Postgres, right, generally that's done master and many slaves. It's the same for pretty much every database. And this is sort of my order of what I would pick. I would probably pick Saloni first, Loandees, Bucardo, and then pgpool 2. Feel free to Google those terms if they sound interesting. Saloni is developed by a core Postgres developer, used by the .org DNS guys and a whole bunch of other people. Has the longest, most stable history of all these solutions. Loandees and PGQ are developed by Skype, and that's what they use to do all kinds of cross-database jazz. Bucardo is a smaller, sort of newer system, has some fancier features, written in Perl. Some people like Perl. So it's just sort of another one for the purposes of scaling your reads. And then pgpool 2 is this thing out of Japan that's kind of like the animated dinosaur thing. It's really weird and interesting, and you think you might want to have it, but you don't actually know anyone that does. Occasionally it shows up at a conference, and you like play with it, and you're like, wow, that's cool. Yeah, so pgpool 2 would probably be the last one I would pick. It has like the most, like if the feature checklist thing is what you like to judge software by, look at pgpool 2 because it has all these features that look really interesting. It just has sort of the weakest reputation for high scale production websites. So it's last on my list for that reason. Okay. It says talk faster. All right. Scaling writes is basically impossible, so I won't spend a lot of time on it. You can't scale writes using replication, at least not very well. So if you have a write problem, scaling is not your answer. If you're going to try to do it anyways, Bucardo and pgpool 2 are the ones you're probably going to look at. Bucardo can do master-master. pgpool can do weird stuff. So federation. If you're going to get into federation, the thing about federation is the idea is actually you're going to just eliminate the need to have good performance on your database, right? That's the whole point of it. MySQL talks a lot about federation, and it's a pretty popular topic. The MySQL software has no federation advantage, right? Like it doesn't federate better than anything else. I still haven't seen where Drizzle is doing anything that is like really revolutionary that MySQL couldn't do once you've already applied federation principles. The thing is, MySQL community has a lot of talk about this, right? Because they can't scale up their database as well. They run out of hardware solutions at a much lower level. So it's important to pay attention to what's going on at conferences like this because this is where a lot of the federation talk is going to go. And you probably will need to do this at some point. There's different methods. And again, this is sort of new industry and it applies to all databases. It's just that you don't see a lot of people talking about it if you're using like Oracle because you just generally don't look at having 100 Oracle servers as your solution to anything. But essentially, right, horizontal partitioning, application-based partitioning. If you're not familiar with base, I think Google on that will turn up something fruitful. But it's that idea of the data is not ACID. The data is not ACID. It eventually gets consistent, and you can query against it. Two solutions normally used for that are Golconde and Gearman, are sort of popular ones. It's a pretty new field, though. So it wasn't long. That's pretty much it. First one is my website. Second one, company website, where we are hiring, so please check it out. And the last one is US Postgres Foundation, if you're interested. And the next speaker is going to kick me off. Or I'll tell you there's a Postgres spot tonight in the Camino Real. No questions. If you want questions, come to the ball. All right.